Hi everyone, welcome back to Geeks for Geeks practice. Just waiting for others to join and then we'll start with the problem. The problem for the day for yesterday was array subset of another array. And this problem, if you'll see, so this problem has been asked in a couple of companies. Let's see those names. So it has been asked in Qualcomm, Acolyte and other companies. So this is the problem that we'll be discussing today. I'll just wait for a couple of minutes for others to join and then we will begin with the session. So I can see a lot of people have joined. So all those who have joined, please consider giving a +1 in the chat so that I know that my screen is completely visible to all of you and my voice is also clearly audible. And then I can begin with the question for today. Like this is an interesting question. Like it is written easy. So hi Shruti, yes. So great. So this is an easy question, but it can be solved in various ways. And if you'll implement it, so if you'll try to be too much, let's say if you'll be try to do too much of things in this question, then you might face some difficulty. Otherwise, this is a simple implementation based questions. Like the question itself can be a bit tricky in terms in the name array subset of another subset, but believe me, this is a very easy question. So hi Deepti Mai. So how many of you have solved this question? I just wanted to know how many of you have solved this question and what was your approach. Then I can begin with my approach as well. Okay, so let me start with the question. So the question says that you have been given two arrays. One array is A1 and that array contains n elements in it. The second array is A2 and the second array contains m number of elements in it. And the task is to check whether A2 is a subset of A1 or not, right? It has been given that you have to find, your task is to check that whether A2 is a subset of A1 or not. So both the arrays can be sorted or unsorted. It is either these arrays can be sorted or not sorted. It may be assumed that the elements are distinct, right? So let's suppose that in the first array what you have been given 11, 1, 13, 21, 3 and 7. In the second array, let me just copy this test case so that we can discuss upon it. Okay, so let me come to the whiteboard. So if I come here and I'll just copy paste the test case. So once I copy paste the test case, so if you see this test case, so in this test case the value of n, that is the number of elements for this first array, is nothing but 6, right? So number of elements are 6 and what are these elements? 11, 1, 13, then you have 21 and then what is another element? 3 and 7, right? So you have these elements. In the second array, if you see, so m is equal to 6, m is not equal to 6, sorry, m is equal to 4. So in this array if you will see, so elements are 11, 3, 7 and 1. So can someone tell me, like, when can A2 be a subset of A1? What is the minimum condition required where A1 can be the subset of A2 can be the subset of A1? What is the minimum required condition such that, what is the minimum condition such that A2 is the subset of A1? What is the minimum condition? What is the minimum condition such that A2 is a subset of A1? What is the minimum condition such that A2 is a subset of A1? M is less than, right? So this is also very much clear, right? So there can be two conditions. Shruti, you are missing one more condition. You can just try and think of it. So one condition is that for M1, for the array A2, this is the array A2, this is the array A1. So first condition is that M should be less than N. So if you want that your A1 should be a bigger set, and all the elements of A2 should be inside, or like some of the elements of A2 should be in the A1, right? And A1 should be a bigger set. So that means that M should be greater than N. This is the basic condition. Then there is one more condition. Okay, so right. Perfect. This is also equal to also possible, right? What is not possible is what like let us not discuss on this. Like if we directly see, so if in any case if M is greater than N, then you will say no, A2 is not a subset of A1, right? What is the second condition? Can anyone tell me about the second condition? The second condition that we need to see is, in this case you will print no, in all other cases you can have a chance, right? And what is the, you should be having at least one element shall be common, right? Shall be common. Does everyone understand this? Why? Because if at least one element, even one element is common, then that means that it will be a subset, right? Is this clear? Like first of all, like let's say you iterate and you see that no element is present, then in that case it will not be a subset, right? Everyone is getting this point? Okay, so now move on. Let's move on. So what we can do is, first of all what we can do is, we can sort A1 comma A1 plus N. Then what I can do is, I can sort A2 comma A2 plus M, right? First, before that I will be checking. Before that, what I can do is, I can simply check this, that if my M is greater than N, then in that case I'll simply return a no, right? In that case I'll simply return a no. Perfect. This is something that I should be considering. Now after this, what I can do is, I can keep my J at 0 initially, and what I can do is, I can iterate for the bigger array, that is the A1 array, and in this I need to check for every element, like if A of I is equal A of J, right? If this is possible, if this is, let me show you the code for this, like how I have done this. So the code part will be much more clear, and then we can discuss upon it, right? So what I can do is, first of all I can simply sort the array first and array second, and I can check that if M is greater than N, I can simply return a no. Otherwise what will happen in the else part, I can start my iteration from the bigger array, and when the array 1, the element of the first array is equal to the element of the second array, then that means that I can simply do a J++, right? I can move in the smaller, in the subset array, right? In the A2 array, I can keep moving my pointer or the index, and once after several iterations, let's say I check and I know that if my J is equal M, that means that in this case all the elements were checked and J got incremented, because A1 of I equal to A2 of J, that is why I had sorted these. And after this I can simply return a yes, because in that case J is equal to M, so J has reached its limit. So this means that my A2 will be a subset of A1, right? Everyone agrees on this? And if that was not the case, then after the loop I can simply return a no, right? If this much part is clear, if this code is clear to all of you, then please give a +1 in the chat so that I can move to the optimal codes. Is this much part clear? Like how we are checking the subset using sorting? What I'm basically saying is, you sort both the arrays and then you keep a pointer J is equal to 0. If array of I and array of J are equal, then you simply do one thing, and that is, okay, thanks Rahman. So J++, I can simply do a J++, because in that case I can move my pointer of the second array. If A1 is equal to A2, then in that case I can move my J, and I can check that if my J is equal to N, right? If my J is equal to M, that is the what is M? M is nothing but what? A2 dot size, right? A2 dot size, that is the size of A2. So if I reach the end of J2, then that means that I can simply return a yes, because in that case my A2 is a subset of A1, right? And even after this loop, if that was not possible, then I can simply return a no, right? Is this code clear to all of you? What will be the time complexity for this code? Can anyone tell me what will be the time complexity for this code? for the sorting. If you sort both the arrays, if you are sorting both the arrays, then what will be the time complexity? The time complexity will be order of n log n for sorting the first array plus order of m log n for sorting the second array as m log m, right? So this will be the time complexity, right? Because you do not need to consider the linear part, because even after the linear part this will prevail, right? This part will prevail. So that is why the overall time complexity will be nothing but this, right? Okay, perfect. Okay, let's move on. Is there any other approach? Right, n log n, perfect. So okay, now tell me one thing, is there any other approach like how we can do this question? Like if someone tried it, like if you see in the question, if this is not a good approach because it is taking n log n, can we do better than this? And if we can do better than this, then what is something that we can do? Also, I can see a lot of people are watching, so please consider giving a like to this video so that it reaches as many people as possible, right? So now moving on, I want to know, can we do better? Can you tell me any optimal approach? Any optimal approach to this question? Any optimal approach? Okay, one approach can be, let me discuss some of the approaches with you that I have in my mind. One approach could have been that I could have done a binary search, right? I could have done a binary search, but in that case, even in that case, my time complexity would have been n log n, right? Something very close to n log n. So that means that this would have not been optimal, right? Another thing that I can do, besides binary search and sorting, like first approach was sorting, right? First approach was to sort both the arrays. This was one approach. Then next approach was using binary search. What are the other approaches? I want to know from all of you, like what are the other approaches that you can think of? Can anyone tell me about any other approach that they have in mind? Like Shruti, can you tell me? Or Rahman, can you tell me? Anyone else? Can you tell me like what will be the other approach besides sorting and binary search? What else we can do? So you can use a set as well, right? You can store all the values of the a1 or a, either a1 or a2 in the set, and you can take the size. After that you can insert, let's say you are taking a set, right? So what you can do is you can push all the elements of a1 in the set S, and after that you can take out the size. Sz is equal to s dot size, and after that what you can do is you can insert all the elements of a2 into this set S as well. And even after that, if the size if the initial size of the set was equal to the size after inserting the second array, if both were same, so that means that all the elements of a2 will be present in a1, right? If first of all I will insert a1 into the set S, right? And then I take out the size 1. What is my size 1? Size 1 will be S dot size, right? After that, what I am saying, let's insert a2 into the set S, and let's say S2 is my size. After that, S2 is equal to S dot size, right? And what I am saying is, if S2 is equal to S1 dot S1, that means if the size of both the sets are equal, so that will simply mean that all the elements of a2 were present in a1, right? That is why all the elements of a1 was present in the set. So that means that a2, after inserting a2, no new element was inserted, right? So in this way you can see that we will be able to find using set as well. If the size of the set 2 before the insertion of the second array and after the insertion of the elements of the second array is same, then that means that both are subsets, right? Is everyone getting this point as well? Is everyone able to get this point? I just want to know, then I can move ahead, so that I can move ahead. Okay, hi Marcus. Right, what is the another approach that I can have? Someone in the chat has suggested, Rahman has suggested that we can use a hash map, right? So in Java you can use a hash map, and in C++ you can use an unordered map, right? You can use an unordered map, or simply a map which will take a linear time complexity. So you can use an unordered map. We can use an unordered map. And how we can do this using unordered map? Can someone tell me in the chat? Can you explain it again? Sure, I'll explain it again. What you are talking about set, right? What I'm saying is let's declare a set. Let's declare a set of integers, right? And let's say all these elements are a1, right? And this is your set. So insert all the elements of a1 into the set S. Insert all the elements of a1 into your set S, and after that let's say your size 1 comes out to be s dot size, right? S dot size. Now what I'm saying is you take the A2 array as well and you insert all the elements of A2 into the set A1, right? You set into the set S, all you push all the elements of A2 into the set S, and after that you take out the size 2. After that you take out the size 2. If the size 2 is equal to s dot size, if that is the case, then that means that if size 1 equal size 2, then can I say, does that not mean that all the elements of A2 were already present in the set S? That is why my size 1 and size 2 are same, and if both are same, then that means what? This means that A2 is a subset of A1, right? A2 is a subset of A1, right? Because my size is not changing even after inserting the second array, because all the elements that were present in the set after inserting A1 are also present in this set A2, and since all the elements of A2 are already present, that is why my set size is not changing, right? And in this case I can simply return a yes. Else I'll return a no, right? Yes, Shruti. Okay, perfect that you understood. This is an approach. The reason why I wanted to discuss this approach will also take something close to log n time and log n, but still I wanted to discuss this because I thought that it was pretty much important. Now coming to the hash map part, what I can do is in C++ or in Java you can declare a map simply, map of int comma int, let's say MP. After that what I can do is, like, let's say all the elements that are present in the A1, right? So I start my I from 0 and I can do an I is less than n, and I can do an I plus plus. After that what I can do is I can mark all the elements that are present, in this array, right? All the elements that are present in the array A1. Let me just change the color so that we can understand it a bit more. So all the elements of A1 of I, all the elements of A1 that are present in this, I'll mark all of them in the map as 1, right? And what I'll do after that is I'll iterate once again and I'll check that if my I'll iterate through the second array A2, and then what I'll check that for a particular element that is present in A2, if the map does not, for a particular present, let's say for the element A2 of I, let's say for the ith element of A2, if that is not present in the array, so that means that its presence is 0. So this means that A2 of I is not present in the map. If this element A2 of I is not present in the map, then that simply means that my A2 is not a subset of A1, right? That simply indicates that my A2 is not a subset of A1, and in that case I can simply return a no, right? In that case I can simply return a no, and once I come out of this loop, that means that all the elements were present and I can simply return a yes in the end. Is this clear to all of you, like how I am approaching? What I am doing is simply, first of all, I am saying that let's iterate through the first array. Let us iterate through the first array and mark all of the elements that are present in the A1 as 1. After you do this, you iterate through the second array. This is the array A1. After that I am saying that let's iterate through the array A2, and what we can do is, if A2 has to be a subset of A1, then all the elements of A1 should be marked, should be present in A2, and that means that all the elements of A2 at a particular index, at every index, all the elements of A2 should be marked as 1 in the map. Only then it can be possible that A2 can be a subset of A1, right? A2 can be present inside A1, right? So in that case, what if it is not the case, then that means that for a particular A2 of I, if the map is indicating 0, meaning that this element was not present in the first array, right? So this means that that my A2 is not a subset of A1, and in this case I can return a no, otherwise I can return a yes. Does everyone agree on this? Does everyone agrees on this? Like okay, Shrishti has understood it. Okay, let me come to this. So let me just show you the code first, then we can discuss upon the question as well. So I'll 1 second, I'll show you my code. Okay, just 1 second. Let me show you my code for this, like what I have actually done. I don't know why it got so much magnified. Okay, so you can see that what I've done is I have simply taken an unordered map so that my time complexity of storing and retrieving the data is order of n only, right? So this map will take order of n time complexity. Then what I have done is all the elements that were present in the first array, I have marked them as 1. I have marked all the elements that were present in the first array as 1 in the map. After that, I have iterated through the second array, and if a particular element, that is if at a particular index of I in the A2 array, if that element is not present in the map already, so that means that it will be marked as 0. And if some element of A2 is marked as 0, so that means that that element is not present in A1, right? Because if it was already present in A1, then it should have been marked as 1, and since it is not as marked as 1, so that simply indicates then I need to return a no, because in that case, in this case, what this means, that A2, what does this mean? This means that A2 is not a subset of A1, right? This is the case. This is the case. In that case, I can simply return a no. Otherwise, if I iterate through the loop, then I can simply say yes, right? Everyone agrees on this? Just give me a +1 and please like the video. Please like the video and give a +1 if this explanation was clear to all of you. Okay, this explanation was clear to all of you, right? What I can do, what I can say for this case is, what will be the time complexity for this case? Can someone tell me what will be the time complexity for this case? What will be the time complexity? Can anyone tell me in the chat? I just want to know. A lot of you are watching and a lot of you have not liked the video, so please consider liking the video so that it can reach as many people as possible, because we try to bring as simple solutions and approaches to all of you as possible. Okay, so the time complexity will be nothing but order of n, right? What will be my space complexity? Can someone tell me what will be my space complexity? Can anyone tell me? Can anyone tell me in the chat what will be my space complexity? So Shruti is saying order of n. Okay, Rahman, right, you are you are also saying correct, but since what I'm saying is the time complexity will be linear in this case, right? Earlier it was n log n. Earlier it was n log n plus m log n, right? So this was not linear. Now it will be linear. Okay, this is what I am saying. And the space complexity will be nothing but order of n, because we are using an extra map. We are using a map. Order of n time for using a map. Also, you could have done this using set, but that could have taken some time. You can also do this question. You can also try out this question using an unordered set. That solution is also possible, right? So is this solution clear to all of you? Is this solution clear to all of you? How many of you had solved this question? Like after this session, do you feel that you got to learn something new from these approaches, the 2 or 3 approaches that I told all of you? Did you that you could learn a bit more through the approaches that I told all of you? Okay, I can see a lot of people are watching. Please give a like if you haven't liked the video. Okay. Okay. So moving ahead, what I want to say is that let me decrease the size of my screen. Clear +1. Okay, Shruti. Right. So what I'm saying is, just let me open the problem of the day. Okay. So the problem of the day for today the problem of the day that we have on Geeks for Geeks is division without multiplication, division without multiplication, comma division and mod operator. Okay, so this is the like Deepti Mai, thanks a lot for writing yes. Okay, so this is the problem of the day for today, that is 6th of November. So you can solve this question. This question is based on bit operators. Like in this question, you can see this is the problem of the day for today. We will be discussing it tomorrow. I'll be taking this problem tomorrow. The problem name is division without using multiplication, comma division and mod operator. And this is a bit manipulation question, and it has been asked in Microsoft. So tomorrow we'll be taking this question. Today you can solve this, and even I have not solved it, so I'll solve it after this session. So that is it from my side. If you have any doubt, does anyone have any doubt? I can see a lot of people are live, so please consider giving a plus. Please consider liking the video as well if you liked the explanation that I gave. If you like the approaches, various approaches that I gave to this question, please like the video. And this is the problem of the day that is going on today, and we'll be discussing it tomorrow. So you can consider solving this question. Also, if you like the video, make sure to hit the subscribe button and the bell notification icon. One more thing, we bring such video tutorials regularly. Also, we have planned something really good on recursion for you, so we'll be bringing it soon. So that is it from my side. If you have not liked the video, please like the video, and in case if you have any doubt, so you can mention that in the comments, and I'll get back to your doubt as soon as possible. So